Meteorologist Jim Rinaldi, Lebanon County weather, taking a look here at the potential for what could be a pretty significant snowstorm across parts of the mid-Atlantic and Northeast as we head towards this weekend. Now, this is not going to be a forecast per se, as far as, where it's going to snow, how much it's going to snow, nothing like that. It's way, way too far out for those type of details. If people are trying to tell you that they can tell you, yeah, we can get some general idea, but as far as, specifically in one place that I think there's going to be 6 inches of snow in Lebanon or something like that. Well, that's just not possible at this point in time. And if people are telling you it is, they're snake oil salesmen, basically. So, but anyway, here's what we're looking at here, and here are some of the key factors that we're going to be looking at. First of all, this piece of energy here, this is going to be the storm. That right there, that's going to be the storm. And we're starting here. This is the GFS. I'm just using, starting with an arbitrary model to just to show you what the players are here. Quite frankly, I don't think the GFS solution has a prayer of verifying. So as we go out, I'll show you why that is. But that's that. And then these two pieces of energy here are going to be very important as well, because what's going to happen is these two pieces of energy are going to merge, and then they're going to try to form what's known as a 50-50 low. Now, it doesn't mean that there's, flip a coin and whether or not there'll be a low pressure system. No, 50-50 low means there is an upper level low at 50 degrees latitude, 50 degrees longitude, which is approximately right in this region here. Okay, because what that does is it's going to take this, this system is going to be coming in like this here, into this region here. And what the 50-50 low does is it causes the flow to buckle underneath it. And that allows this storm to continue to come this way, tilt negative, and develop a low pressure system. And then you get one piece coming up like this, secondary forming off the coast. And then with the 50-50 low there, what then happens is the heights along the coast start to back, kind of like that. And I'll show you this as we go forward here. And then this low pressure system is able to come up the coast. And that's when you get your good snowstorms, when you have a situation like that. Now we'll go ahead here, forward in time here, and this is out to 24 hours, and now we can see here we can see here these two pieces of energy are starting to come together in this region here. So that's good. We want to see that. We'll go out here another frame, and we can see now they've completely merged up in that region there, right here. Here the two upper level features have merged. Now watch what happens though as we start going forward. Okay, now good, we're moving up towards that. Remember I said that 50-50 position up here, right around here. It certainly looks like it's heading that way, right? We'll go out here to 96 hours, looking good, still moving up, still a nice closed circulation. But now watch what the GFS does here. It just weakens it, opens it up, and shoots it right out. Okay, and I don't know why that would happen. I don't see any reason for that to happen. And also here, I think we're seeing the GFS progressive bias here as well. Because watch what happens here as we go back here. Okay, here we have a pretty amplified pattern here. I mean, it's not greatly amplified, but we have a ridge here, we have a trough, and it comes across like that. But we go forward in time, and look what the GFS does. Okay, it takes the Pacific Jet out here, very progressive, and it just pretty much flattens everything out. There's some ridge here, but I mean, for the most part, we're just looking at a very flat pattern like that. No real strong energy being shown anywhere there. I think that's showing typical bias, typical GFS bias. We'll go here to the, what are we looking at here? This is the GFS of the humidity, the vorticity panel. So same basic idea. We're still seeing it come out here, and there's 168 hours, and you can see that it's very nondescript pattern here. There's the energy is back here. There's a weak piece out here, and you can see, looking at the surface reflection, what that does. Here, we'll go back here. Here's our 120. Go to 144. Very weak energy. Nothing really showing up. And watch what happens at the surface. Okay, you have a weak wave here along the Gulf Coast. that just comes out, ends up right here. And then because it's really, there's that remember I said that 50-50 block just kind of opens up and just shoots out. Well, watch what happens to the low pressure system. It just weakly goes offshore. Starts to intensify a little bit up here, but I mean, it's very weak still up there. Now we'll look at the parallel GFS and show you the difference here. Now here's 120 on the parallel GFS. And the parallel GFS is the, it's going to be the replacement eventually for the regular GFS. It's a higher resolution model, so it should be able to see things in more depth, theoretically. Now, first of all, remember now on the we'll call it the old GFS, this, at 120 hours, this feature here had opened up and was moving out like this up here, okay? Here, it's completely opposite. It's closed off and it's way south. It's south of 50-50. You know, this is more like 40-45 or 45-45 or somewhere in that area there. We want this up here like this. You know, so totally opposite scenarios here. And also remember on the regular GFS, okay, we still have our strong Pacific jet out here. Okay, but it doesn't lose the energy across the continental United States. And you can see here, we have a southern branch here. We have a very strong northern branch feature here, maybe too strong in this particular case. Yeah, the old GFS, we hardly had anything. So, and I'll show you here, we'll go forward. And you can see here, we have a lot of energy coming across now. Same with the, here's 168, very strong upper level low. Maybe a little bit too far north, but we'll have to see there. But I'm not worried about those details at this point in time. But now let's look at the difference here and the surface panels. And remember, okay, this is 120. And if you remember from the old GFS, all we had was this weak little wave down in here like this. There's a little wave down there. Okay, here we have a closed circulation low. Right there, we got closed circulation in there. And watch what happens because we have that low that, well, hopefully to end up being a 50-50 low, and we have much more energy coming across in here. Watch what happens in this low pressure system, okay? Here it is, clearly off the coast. Well, first of all, you can see here what happens, okay? We'll look at it here. And the first piece of energy is moving up into the West Virginia area, and here's our secondary low forming off the coast, which I said should be the case that happens. We'll go forward here, and look at this thing just bomb out. Okay, that's because of the low pressure system sitting up, the upper level low sitting up in here. It's blocking the pattern. The flow is backing. I'll show you that here. We'll go back to the 500 millibar chart. You can see here there's some backing flow in there, and that's causing this low pressure system to come up like that. So, you know, I mean, the difference between the GFS and the parallel GFS are just astounding, you know, as far as, you know, its evolution of things. I think the GFS, as I said, is way too progressive. It's way too fast. It flattens out the flow too much, and I think it's just total garbage. Canadian kind of agrees with that. Yeah, the Canadian has a little bit of a different solution now, and here's our 120, and you can see there's you know, there's our 160, and now this is moving it much faster because like the GFS, it is moving that 50-50 low out very quickly. So that's why you're having this system move out much more quickly, but still we are still seeing much more of a system than the GFS is showing. Okay, and this is also much more amplified than last night's Canadian model. So here's our low here. We'll go out forward. And you can see here, I mean, this is 24 hours later, and it's just racing along here. But the key thing is it is picking up on an intensifying storm system, and that's what we're looking for right now. You know, we're not looking for the details. Oh, is it 20 miles east of Long Island? Is it 15 miles east of Cape Hatteras? No, that's not important right now. Okay, that's not what we're looking at. Is there a signal for a storm? Yes, there is. Are there the ingredients to get a storm to form? Yes, there are. Are there setups that will cause the storm to intensify and then move up the East Coast? Yes, there are. That's the important stuff to be looking at right now, and that's what we're looking at, and we are seeing that. I think there is going to be a storm, pretty significant storm at that. And now, where exactly the heaviest sets up, we'll just have to get those details down later. But that's what I wanted to show you, is these things that we're looking at, the differences in the models, how difficult that makes it to do these forecasts, and trying to sort out what is going to be the most likely solution. All right, that is it. I am meteorologist Jim Rinaldi for Lebanon County Weather.